What is an energy efficient motor? Motor efficiency is the ratio of mechanical power output to the electrical power input, usually expressed as a percentage. Considerable variation exists between the performance of standard and energy efficient motors. Improved design, materials, and manufacturing techniques enable energy efficient motors to accomplish more work per unit of electricity consumed. Energy efficient motors offer other benefits because they are constructed with improved manufacturing techniques and superior materials. Energy efficient motors usually have higher service factors, longer insulation and bearing lives, lower waste heat output, and less vibration, all of which increase reliability. Most motor manufacturers offer longer warranties for their most efficient models. What efficiency values should I use when comparing motors? When comparing motor efficiencies, be sure to use a consistent measure of efficiency. Nominal efficiency is best. Nominal efficiency is an average value obtained through standardized testing of a population of motors. Minimum guaranteed efficiency, which is based on nominal efficiency, is slightly lower to take into account typical population variation. Minimum guaranteed efficiency is also less accurate because the value is rounded. Other efficiency ratings, including apparent and calculated, should not be used. Why is improving motor efficiency important? Over half of all electrical energy consumed in the United States is used by electric motors. Improving the efficiency of electric motors and the equipment they drive can save energy, reduce operating costs, and improve our nation's productivity. Energy efficiency should be a major consideration when you purchase or rewind a motor. The annual energy cost of running a motor is usually many times greater than its initial purchase price. For example, even at the relatively low energy rate of 50.04 kilowatt per hour, a typical 20 horsepower continuously running motor uses almost $6,000 worth of electricity annually, about 6 times in its initial purchase price. When should I consider buying an energy efficient motor? Energy efficient motors should be considered in the following circumstances. First, for all new installations. Second, when purchasing equipment packages such as compressors, HVAC systems, and pumps. Third, when major modifications are made to facilities or processes. Fourth, instead of rewinding older standard efficiency units. Fifth, to replace oversized and underloaded motors. And the last one is as part of a preventive maintenance or energy conservation program. Lastly, should I rewind a failed motor? Although failed motors can usually be rewound, it is often worthwhile to replace a damaged motor with a new energy efficiency model to save energy and improve reliability. When calculating operating costs for rewound motors, deduct one efficiency point for motors exceeding 40 horsepower and 2 points for smaller motors.
Now we will move to the next part is methods to measure efficiency on low voltage induction machine. But first, we will know about the definition of efficiency. In general, efficiency means peak level of performance that use the least amount of input to achieve the highest amount of output. But in electrical motor, efficiency is a ratio between power output and power input. Next, low voltage induction machine means three-phase electric motor whose rotating power is based on electromagnetic induction. Now we will know about the methods. First method on how to measure efficiency is first, power divided by input. Efficiency in this context is a decimal varying from 0 to 1.0 or sometimes a percentage. Usually, the more powerful the motor, the more efficient it is expected to be. And the formula is E equals to 0.7457 multiplied by HP multiplied by load and divided by power input. Second method is efficiency of three-phase induction motor. In this method, we will have two sub-methods. First is efficiency is defined as the ratio of the output to the input, and the formula is E equals to output divided by input. Second, rotor efficiency of three-phase induction motor. And the formula is E equals to rotor output divided by rotor input. Third method is induction motor efficiency with shaft power and input power. Shaft power means mechanical power delivered by motor, and the equation is E equals to power mechanical divided by power input. And the last method is efficiency with induction motor slip, and the equation is E equals to 1 minus S. Induction motor slip S can be calculated with formula S equals to synchronous speed minus running speed divided by synchronous speed.
The ways to improve efficiency of electric motor. First, regular inspection. Regular inspection of the insulation for sign of wear can help to keep your electric motor running at full efficiency and prevent low resistance from resulting in machine failure. Second, protect against electrical overload. The installation of effective overcurrent protection can detect overcurrent before it becomes a problem, interrupting supply and protecting against overload. This will enable the motor to operate at maximum efficiency while reducing the chance of breakdown. Third, keep cool. Ensuring that the operating environment is keep cool is the easiest way to keep the temperature of a motor down. This will help to prevent breakdowns, increasing the efficiency of your electric motor. Fourth, monitor vibration. It's important to monitor vibration levels as excess vibration can cause the motor to fail prematurely. This can help to ensure that the motor is able to run at full efficiency and reduce the risk of premature motor failure. Fifth, protect against contamination. Keep work areas, tools and fixtures as clean as possible can reduce the chance of contamination coming into contact the motor. It also helpful wherever possible to position motors away from grinding machine and other equipment which produce large amount of contamination. This will reduce the opportunity for contamination to enter the motor, keeping efficiency at highest possible level and reducing the likelihood of machine breakdown.
Okay, for the next part, we got tasked to analyze the cost saving and payback periods by using the energy efficient motor. In this slide, we're gonna show you some example and calculation by using the energy efficient motor. For the first, which is payback period, it is a simple payback calculation identifying motor that could be exchanged for more efficient motors at a minority gain. In this energy efficient motor, we got four formula, which is the first equation is kilowatt save, the second equation is energy save, the third equation is total annual cost saving, and the last equation is payback period. Okay, for the first equation, which is kilowatt save, we have to know the component to get the answer, which is HP is motor nameplate rating, L is load factor of percentage of full operating efficiency standard, which is a standard motor efficiency under actual load condition, efficiency HE, which is energy efficient motor efficiency under actual load condition. In equation 2, it is energy save, which is we have to got the value from kilowatt save and multiply by annual operating hour. For the third equation, we have to cut our kilowatt save multiply by 12 multiply by monthly demand charge plus with our energy save multiply by energy charge. So we got answer for our total annual cost saving. And for the last equation is payback period, which is simple paybacks. We have to got our price premium multiply by discount factor divide by total annual cost saving.
Assalamualaikum, my name is Hafizi bin Mohtar. Today I will explain about the example of calculation. The following analysis for a 75 lib DEFC motor operating at 75% of full rated load illustrate how to use 1 to 5 to determine the cost effectiveness of purchase and energy efficient. From the equation 1, we can calculate is kilowatt saved. From this formula, we can get 75 times 0.75 times 0.746 times 100 over 91.6 minus 100 over 94.1, and the answer we can get is 1.21. Okay, from the equation 2 is energy saved. Formula for energy saved is kilowatt saved times annual operating hours, and we can get 8,000 hours times 1.21, and the answer we can get 9,680 kilowatt hours over years. From the equation 3 is total annual cost saving. From the equation we can get the answer is 368. In this example, installing an energy efficient motor reduce your utility by 368 per year. The simple payback for the incremental cost with an energy efficient motor purchase is the ratio of discount list price premium. From the equation 4 is payback period. Simple payback years equal price premium times discount factor over total annual cost savings, and we can get 747 times 0.75 over 368, and we can get the answer is 1.5 years. Okay, thank you.